Today we will solve one numerical from coupled circuit. Here we can see the question is draw equivalent circuit for the coupled circuit shown in this figure and find the voltage across the capacitor. So we have to draw the equivalent circuit for this coupled circuit. So we assume that the current is entering at the top of the left coil and place a dot at this terminal. Then the flux direction for this current will be in upward directions. Now by Lenge's law, the flux at the right coil must be upward directed to oppose the first flux. In the right hand side, current is leaving, so we will place a dot over here, and two resistances of 5 ohms are connected in each coil, and one capacitor is connected in between them. So this way we can draw the equivalent circuit. Here the voltages are given in polar form, so we can convert it into rectangular form by say 10 angle 0 degrees equal to 10 cos 0 plus j sin 0. So this one is equal to 10 volt. Similarly, this is 10 angle 90 degrees equal to 10 into cos 90 plus j sin 90. So it will be j 10 volt. In these connections, the two coils are connected in series in such a way their induced EMF are of the opposite polarity. That is, in coil 1, current is entering the dots, and in coil 2, current is leaving the dots. So the mutual inductance between them will be negative. Now we have to write the KVL equations. This is the most important step for solving coupled circuit problem. So for mesh 1, we have to find out, we have to write the KVL equations. Here the voltage is equal to 10 volt. So I1 into 5 plus J5 minus J10 minus I2 into J10 minus J10 apart minus 2J2I2 is equal to 10 volt. As this one is the mutual inductance is J2, and the at the symbol this will be negative. So J2I2. So from this we have to resolve it. The value of I1, we have to find out I1 and I2. This is the first equations. Now we have to write the KVL for mesh 2. So in mesh 2 we can see this is 5 plus J5 minus J10 into I2. Now current I1 will be in opposite directions. So this is minus J10 into I1. So this is minus minus plus. So this is J10 will be plus. Now from this we can write. So this is J10. So this is the now we from these two equations we will write the matrix form. So in matrix form we can write the coefficients of I1, I2. So from this we can find out the value of I1 and I2. So I1 is equal to del 1 by del and I2 is equal to del 2 by del. So the value of I1 is equal to del 1. Del 1 means we have to replace the first column with 10 at J10. So this way we will solve it. So this is equal to 10 into 5 minus J5 minus J square 10 into 8. So it's 80. J square means minus 1. So it will be plus 80 and in denominator it will be 64 plus 64. So we are getting the value of I1 in rectangular form. 130 minus J50 by 64 minus J50. So the value of del is actually this is 64 minus J50. So in the next and we have to find out the value of I2 which is del 2 by del. Here we have to replace the second column by 10 and J10. So we can see this way we can find out the value of I1 and I2. So whenever solving this type of calculations, do it sincerely. Our objective to find out the voltage across the capacitor. Here we can see the capacitor voltage across the capacitor is equal to I1 minus I2 into XC. So I know the value of I1 and I2. So accordingly I will find out the difference between I1 and I2 in rectangular form. So this one is the value of I1 and I2. I1 minus I2. Now we will multiply it by minus J10. So this is in rectangular form. So we see in polar form we have to find, we will find by using a calculator. Here I have used one website. So here you can see I am putting the value of rectangular form and we get the value of minus 200 minus j 800 is equal to 824 angle 255 degree. And by putting the value of, finding the value of 64 minus j50, here the angle is 322 degree. So you have to divide 824 by 81.22. So you will get 10.145 angle. You find out the angle difference in angle. So it will be minus 66.04. So the voltage drop across the capacitor is 10.145 angle of minus 66.04 volt.